So where I left off was talking about high availability, which is something we were suffering from here. Application failure, hardware failure, not sure what was going on. Okay, then scalability. You want to scale out to meet your peak traffic demands. That's another challenge. Another is lifecycle management. How do you actually maintain the live service running through all the changes that you have to do with your software over time? So the focus of this talk is on, I'll first talk about data scalability, talking about how our storage system scales out to meet your traffic demands and what you need to know about what we can do there. Also for scaling computation and workflow, I want to talk about how do you actually build scalable computation using a workflow queue model. And then finally, lifecycle management, how do you deal with upgrades and versioning? So when you actually get your allocated service running up in the cloud, you have allocated VMs. And this gives you amount of local storage and memory to use for your application as temporary storage for caching. So that's sort of one form of storage that you have, but it's only temporary storage here. Now, then you have persistent storage. To store your data persistently, you should look at using Windows Azure Storage or SQL Azure. Windows Azure Storage provides storage in the form of blobs, tables, and queues. And in the near future, it'll provide drives. And SQL Azure provides access to a relational database in the cloud. Now, this talk, I'll focus on basically blobs, tables, and queues. For the data scalability part, I gave a talk on drives and blobs yesterday. So you can check that out if you want more information on drives. Now, the first thing I want to talk about, okay, what are these blobs, tables, and queues? Well, blobs provide an interface to store your files up into the cloud, where a blob is you can think of it as a named object where you can store metadata with that object. Tables provide access for structured storage, where a table is a set of entities, and an entity contains a set of properties. And queues provide reliable storage and delivery of messages for your application. Now, in order to store these objects up into the cloud, you first need to create a storage account. And when you create your storage account, you put all of your blobs, tables, and queues into there. So I'm going to talk about first, give you an idea of what we basically have been building for the commercial availability in terms of the scale of a storage account. And to go beyond that scale, you can use multiple storage accounts. So for our design that we've been shooting for commercial availability, a storage account can hold up to 100 terabytes of data. If you want to go beyond that, you would use multiple storage accounts within your subscription. And then the target throughput we have here for a storage account is on the order of a few hundred megabytes per second of traffic, or a few thousand requests per second in terms of transactions. And just to give you an idea of that scale, we have a few services running in-house that are using these storage tables, queues, and blobs. And one of them is doing around 250 million transactions per day. And another one's doing 500 million transactions per day. Okay? Now, of course, the actual throughput that you'll get for your service will depend upon your workload. But I wanted to give you an idea of sort of the design we've been shooting for our commercial availability. Now, one other thing I want to talk about here is, for high throughput blob delivery to your end users, one thing you might want to check out is our Windows Azure Content Delivery Network we recently made available. This allows you to deliver your blob content with very high bandwidth around the world, where what happens is if you're actually delivering your content with the CDN, it will get cached on one of our 18 global edge locations and then serve the blobs from there to the end users for very high connectivity. Okay, so now you have sort of an understanding of sort of the throughput and the capacity of a storage account. I'm going to talk about the actual objects themselves. So we actually group your objects, your blobs, entities, and messages into what we call partitions. Now, we automatically load balance these partitions out across our servers, and we monitor the usage patterns of these partitions. So basically, we can load balance the load to these partitions out across our servers to meet your peak traffic demands. So let's go through how this sort of works with a pictorial example. So here's sort of a high-level picture of our storage architecture at a given geolocation. You have requests that come into the front end. Okay? The front ends actually know where to send these requests to in terms of back-end servers. So the requests will get forwarded to one of these back-end servers. Now, note here that the backend servers are part of a large distributed file system in petabytes of data. So each storage at this backend contributes to part of this large distributed file system. In addition, each backend knows how to access the data from all the other backends. Okay? So what this allows us to do is take these partitions we want to serve your data from, and we basically say, this backend will serve these objects for now, this partition. But it also allows us to move these partitions around and basically serve them from any of the other servers. And when we actually reassign these partitions, we actually aren't moving any data around. We're just saying that this partition, like your messages, table entities, or blobs, are actually going to be served from a given backend. Okay? So shown here, we have 4 backends serving a handful of partitions. Now let's take, for example, what goes on for load balancing. So here I've added some meters to show basically the health level of the server. Green means things are going well. We're serving all the requests within our SLA and with low latency. Now, let's say a backend server gets a spike of load due to the partitions it's serving. Okay? Now, our master system realizes that, and it will decide after some analysis, well, maybe we should take 2 of these partitions, offload them, and then reassign them to these 2 other servers to serve the partitions from there to balance out the load. And this brings us back down to a healthy, well-performing system. Now, just to reiterate, when we actually do this load balancing, we're not actually moving any data around. We're just saying, instead of serving that partition from backend 3, serve it right now from backend 2. Now, there's a couple important points I want to go through this. One is the time between offload of a partition to the reassignment and the loading of serving that data is on the order of seconds. And we really made this fast so it wouldn't affect the SLA for your accessing your storage system. Now, another thing to note is the time to load balance once we actually determine that there's a spike in traffic is on the order of minutes. And this is because we don't want to overload balance the system. We only want to really move your partitions when we actually know we have to. So it actually takes a few minutes to say OK, what's going on with this backend server? Where should we actually move partitions? And then we'll do the offload and reload. Okay? So that's how we actually, at a very high level, how we load balance the access to your data objects for blobs, tables, and queues across our file system. Now, so why is this important? Well, the load balancing, it is an internal part and concept of our Windows Azure storage system. But this is a key part to allow us to automatically scale out and monitor what's going on with your data and then scale it out to meet your peak traffic demands. So what is important about this for your application? Well, the important point here is that you sort of want to be aware of and know that all of your objects with the same partition key value are always grouped into the same partition, which means that you'll go to a backend server and serve those requests out. So for our blobs, tables, and queues, what is the partition key we use? Well, for blobs, we use the blob name for the partition key. So what this means is that if you have a blob container, we can actually take that blob container and spread the blobs out across many backends. Okay, so you can put as many blobs as you want within the container, per se, and we'll spread those out and serve the content through them across many backends. On the other hand, for messages, it's a little bit different in that the partition key for messages is actually the queue name. So this means that all of your messages that you put into a queue are actually served from a given backend. And this actually obviously means that there's a fundamental limit on how many transactions a queue can do. Similarly, for entities, we allow you, as the application developer, to define what the partition key is for your tables. And all the entities with the same partition key value are grouped into the same partition and ultimately served from a single backend, one of the backends. And that also means that for a single partition, or all the entities with the same partition key value, there's a fundamental limit on how much throughput you can get. Now, if you want some more information on how to choose a partition key, Jay Herodis gave a talk about this yesterday in a deep dive into Windows Azure tables, so I recommend checking out that talk if you're interested. So what does this mean for the performance of my storage that I'm actually using in Windows Azure? Well, shown here is the target performance we've been shooting for the commercial availability. So the throughput for a single queue is targeted to be up to 500 transactions per second. And the throughput of a single table partition, meaning all the entities with the same partition key value, is targeted to be the same thing, up to 500 transactions per second. Now, and then for blobs, we're targeted at, for small reads and writes, around 30 megabytes per second, and for large reads and writes, around 60 megabytes per second. Okay? So I want to give you an idea here of sort of the targets we're shooting for commercial availability for these partition boundaries. Now, another thing just to briefly talk about is the latency. The typical latency we see for small transactions is around 100 milliseconds. Now, but once in a while, if you have that back end that gets overloaded really quickly with a lot of load, while we take the time to basically decide how we want to load balance this, the latency could actually spike up to a few seconds. So you should be aware of that for your application. But once it's load balanced, the latency should go back to the typical 100 milliseconds latency. Now, one other thing around latency I just want to briefly mention is that you actually have this local disk as well as memory at your application layer. And if you actually really want 10 milliseconds latencies for your working set, you may want to also look at adding a caching layer at your application. So adding caching to your application layer can allow you, if you can fit your working set into there, to have really 10 millisecond latencies for your dominant requests. And then you can fill those requests from the back-end storage service if you get a cache miss. OK, now I want to move on to talking about scalable computation and workflow management with Windows Azure. So when you actually write a program for Windows Azure for the computation, you specify what's called a service model. And so what's described in the service model? Well, for the service model, you describe what are your roles that you want to run. And those roles have associated binaries. And then you describe how are these roles connected. OK, so just for an example, assume we have a photo processing website we want to run. And so we may have a front-end web role that takes the incoming request that we want for the photo processing. And we also might have a worker role that actually processes those requests. Might do red eye reduction or cropping or something like that. So that defines the two types of roles we have for this example service. Then the next thing we need to define is how are these connected? Well, with the service model, you define that, OK, I need a VIP to take incoming traffic from my web role. And then for my worker role, I need to have that taking incoming traffic from the web role. So here we have a simple service model describing that photo processing service. Now, there are a couple other things you specify for your service, such as how many instances of each type of role do you want to run, maybe some application configuration settings, and as well as how many update domains do you need to basically do upgrading for your service. And I'm going to go through the upgrade domains later when I talk about lifecycle management. So with this simple service, let's take a look at this in a little bit more detail. So we have our web plus worker role service model. And if we only have one instance of each role here, that's not too good for availability. So here I have a failure if I only have one instance of this, and now my service is unavailable. Okay? So one very basic but still important to point out is that you need to have multiple instances of each type of role running in your service if you want to have availability. So let's add that. So now we have 2 web roles and 3 worker roles. So if a web role goes down, the service is still available. It might not have as much incoming throughput as it did when it had 2 web roles, but it's still available. Now, the other type of thing you want to have for your service is how do I scale it out? Well, you want to have your roles built so that they basically are cookie cutter. You could actually just multiply them out and increase them. And our Windows Azure solution allows you to just go in and easily say, OK, increase my number of roles from N to Y, or decrease it if you need to. So here, let's say we have more incoming traffic than the 3 worker roles can deal with. So let's add 2 more worker roles. And you can easily do that. The worker roles all perform the same functionality, so you can just deploy them. And then the service model will allow you to basically hook these up. OK. So just to reiterate those 2 best practices, even though they're fairly obvious, but they're very important, which is due to application failures, upgrades, hardware failures, you want to make sure you have multiple instances of each type of role running so the service can stay available. And then as you scale out your application, you really want to have your roles to be basically very identical and to perform the same functionality so you can just cookie cutter them out and scale them up and down as you need to. Now, what I've described so far is a basic workflow pattern. You take your work items from your web front end, you feed them to worker roles, and you do the work. Pretty basic. Another part that some services have for this sort of workflow pattern is they may have something that actually breaks a job into these work items. This is often called a map step. They also may have a step which takes the results of the work items, aggregates them together, and that's called a reduce step. So now I want to talk about how do we actually take this workflow we've been talking about and actually make it reliable. And we do that with Windows Azure by putting a Windows Azure queue between your producer and your consumer of the work items. And so this is called the worker queue workflow pattern. So you have our example photo processing application here where you have your web roles producing items, work items for the worker roles. If you put them in the queue, you can then put it in there, forget about it, and know that this message will make it to a worker, and the worker, if it uses the queue correctly, will guarantee that this message will be processed. So let's go through that in a little bit of detail. So what are the properties of this queue that allow that to happen? Well, the Windows Azure queue provides guaranteed delivery of messages with a two-step consumption model. So what happens here is that a worker will dequeue a message from a queue, and that queue message will become invisible for a certain amount of time. Once the worker is done processing that message, it will then delete the message from the queue. Okay? Now, if the worker crashes before it can delete the message, well, then the message will become visible again for another worker to consume it. So let's just take, for example, let's say we weren't actually doing this with the queue. If you actually just communicated the message from the web front end to the worker, and the worker crashed, you would have lost the message. So the whole point about putting the message in the queue is that to make it durable. And the two-step consumption model guarantees that some worker will be able to get the message again to start processing it if the worker that was processing it fails. Okay. So what are a few other properties of the queue? Well, one is when doing with this, implementing this model is that a message may be processed more than once. Okay. And how will this occur? Well, if a worker role processes a message and gets almost done with it, it may crash before it actually can delete it from the queue. That means that the message will now become visible again in the queue for another worker to process. So the message effectively got processed twice. So you need to make sure when you deal with your workflow that the fact that a message could be processed twice. In addition, since these messages get passed to worker roles which can crash, that crashed message may become visible again later, effectively meaning that the messages that you put into the queue are being processed out of order. We do offer best effort FIFO for the queue, but when you actually use the queue for this worker flow model, you should assume that the messages can be processed out of order. Now, one important thing here is that since a message may be processed more than once, you really should make your work idempotent, your work items idempotent. Okay? You really want to make your work items repeatable so that they can be done multiple times. And if you have a work item that actually you think doesn't fit into that model, what you typically can do is actually take that work item and break it up into multiple steps where each additional step in there is idempotent, and then feed that through the queue. Okay, so and there's additional details on the Windows Azure queue in terms of dealing with the failure issues here, and actually the invisibility times in the talk that Jay gave yesterday. So see SVC 09 if you want more details. Now going back to our basic workflow pattern with Windows Azure of using a queue between your producer and consumer roles, you can actually just stamp this out. So let's say we actually want to add another worker role at the end of this that actually does the billing part of our pipeline. So we could actually stamp this out where we have a web role that takes the incoming photo requests, some worker role A's that actually processes the photos, and then it feeds basically what it did to another queue with a worker role B actually doing the billing. Okay? So you can actually just stamp this pattern out to get a reliable workflow for your application. And then you can scale the worker roles up and down as you need to meet the scale of the traffic that's coming into your application. Now, in doing this, you also might have what we call a job manager to sort of monitor and control the overall workflow pattern. And this is a piece of the puzzle or the service that you would add to the service yourself. So what would a job manager do? Well, the job manager can potentially generate the load for the queue if it needs to, for the work items. And then this basically would distribute the work items to the queue. It could monitor the progress of the queues as well as the workers so that it knows that, well, I need to increase or decrease the number of workers I have, or maybe add more queues or decrease the number of queues I need. And finally, for some applications, the job manager could also aggregate the results together and send those back to the customer. Now, I'm just showing this particular with a picture. Here we have a job manager that takes a job. It could actually split that up into work items, feed it into the queue. Now, one thing I didn't talk about earlier, which is the size of the message you can put into the queue can be up to 8 KB in size. So if you need to put something into the queue larger than that, you typically would put it into a blob and then put the pointer to the blob into the message. Then the workers will take those items off the queue, put them back into an output queue, for example, and then the job manager could consume those results and send them back to the company. So there's one company we've been working with the past few months called Risk Metrics. And they're a financial company focused on risk management where they need to run daily financial simulations and market simulations. And they're currently using Windows Azure with 2,000 worker roles. And they plan to ramp that up to 10,000 worker roles next year. And they basically use this exact same job manager workflow model, where they take the results that are actually produced by the workers and then aggregate those together and then send them back to the company. Now, one thing that they dealt with when actually doing this up to the scale of 2,000 is that some of their work items actually run really fast. So they found that they actually had to deal with how to actually increase the throughput of my queue if I'm just using one queue in my system. Because I talked about earlier, the queue is designed for commercial availability to scale up to about 500 requests per second. But they wanted to do more than that. So what did they do? Well, one thing that they're doing right now is that they actually group together multiple work items into a blob and then point the message that they queue up for the work item to the blob. So what they did was group 10 work items together per blob, and that effectively increased their queue throughput by 10-fold. So instead of queuing up every single work item, each message in the queue now represents 10 work items. So they're currently using that right now, but they're also looking at using multiple queues and using the job manager to determine when to potentially add a queue or delete a queue, as well as determining using the job manager potentially to assign to the workers which queues to use. Though you could also have sort of a random strategy where the workers could list available queues with list queues and then randomly pick one. It's basically up to sort of the model that your application would want to use. Okay. Now, one final thing I want to talk about in terms of this workflow, some customers have asked that, OK, I actually have really long running work items. Okay? So if my worker role crashes, yeah, another worker will pick that up and start processing that message, but I don't want to have to go back to the beginning of the work item and process it from the start. Well, one sort of straightforward thing you can do is break your large work item into multiple steps and then just have a progress table to track where you are. So when you dequeue a message, we've broken this work item up into multiple steps, and we keep track of the progress of these work items in a progress table. So when we dequeue a message, we can keep track of, after each step, where we are in processing that message or that work item in the progress table. So if we crash, another worker would actually take that work item later and start processing it. And it can actually look up the work item or the message in the progress table and figure where to continue from there. Okay? And there's potentially other ways to do this. So now that we've talked about how to actually build scalable applications with Windows Azure using the worker queue model, I want to talk about lifecycle management. In particular, I want to talk about upgrades and versioning. We recently released a feature for our service to provide in-place rolling upgrades. Now, what this allows you to do is to specify for your service how many upgrade domains you want. Then all of your roles are broken up into these n upgrade domains. So let's just go through a quick example. So let's say your service has 6 instances of a web role and 9 instances of a worker role. And let's say we specified 2 upgrade domains. Well, that means we will group your running instances into 2 domains with a breakdown like this, where upgrade domain 0 has 3 instances of the web role, 5 instances of the worker role. And upgrade domain 1 has 3 instances of the web role and 4 instances of the worker role. Okay? Now, typically you use around, let's say, 10 upgrade domains. But you could use less, etc. If you use 10 upgrade domains, that means that when you upgrade one domain, 10% of your resources are being restarted at any given time. So when you do this rolling upgrade, the way it works is that it walks each upgrade domain, upgrading the binaries for that domain, one domain at a time. So when I start this out, I'll upgrade domain 0. That means these 8 roles, the 3 web roles and the 5 worker roles, will be restarted. But we still have upgrade domain 1 running to maintain the availability for our service. Okay? Then next, after upgrade domain 0 is done upgrading, we'll then move on to upgrade domain 1. That's sort of the basic concept of how that works. Now, what are the benefits of this? Well, this helps minimize availability loss when you do your upgrades because only one domain is being upgraded at a time. It also allows local state to continue to be used across an upgrade because you're just re-upgrading the same role where it was running instead of doing another approach which we have, which is a VIP swap. Now, finally, a very important feature of this is that it really allows you to catch your upgrade issues early. So since you upgrade one domain at a time, after you upgrade one domain, what you typically would do for your service is you check to make sure everything looks well, everything is healthy, and then go on to the next upgrade domain. This definitely helps catch upgrade issues very early on because if you catch an upgrade domain issue, in let's say domain 0, you can then roll back to the prior version of the binary. Or you could actually get a hot fix and then deploy that starting at upgrade domain 0. I can't tell you how crucial this is to catching these issues early and helping to maintain the availability of your service. Now, there's another talk actually today at 10 a.m. by Sriram on automating the application lifecycle, and I encourage you to see that. Well, he'll actually go into the details of all the new automated management features we are releasing for Windows Azure for our commercial availability. Okay, so now we understand how in-place rolling upgrades work. I want to go through 2 examples of using this for upgrading versioning. Now, when you're using rolling upgrade, you have to keep one thing in mind. Probably more than one, but one very important thing. You always want to make sure that you understand you have the old version of the service running side by side with the new version of the service while doing your rolling upgrade. Okay? So why is this important? Well, this means that you really make sure that you version everything. You have to version your protocols, version your schemas, and version even your message formats per se. Okay? So I'm going to use 2 examples to go through and show how this works and why this is important. I'm going to go through doing a protocol change between 2 roles, as well as doing a Windows Azure table schema change. So let's dive into that. So for the protocol change, assume you have 2 roles talking a protocol version v1. And you want to switch them to talking a protocol version v2. Now, we now release the ability to actually talk between roles with TCP. So assume we have 2 roles talking where we want to do this protocol change. And this is really a 2-step process. So the first step is basically you want to upgrade all your roles so that they understand the new and the old protocols. But all the roles still send the version 1 protocol. And the reason why that's critically important is because you still have old versions of the roles running, only speaking that v1 version of the protocol. But this new role that you actually upgraded to, it actually understands both protocols and can respond to them. Then the next step is basically you want to trigger the use of the new version. Once we have all the roles so that they are still speaking just the first version of the protocol, but they understand both, you want to basically do it. You basically want to trigger through another upgrade using the new version 2 so that you can actually do the conversion. So let's go through this in an example. So here we have an example where in our service, we have a web role serving our incoming requests, and we've added a caching role to our application layer. And these web roles and caching roles are speaking TCP with their own protocol. And in this example, what we want to do is we want to take the web roles, which are running binary version 1, and we want to upgrade them eventually to binary version 2, speaking protocol version 2. So right now, they're all running version 1 binary and speaking protocol version 1. And notice I have 3 upgrade domains here, upgrade domain 0, 1, and 2. So the first step of our process is we want to upgrade the roles to understand both versions of the protocol. But they're still sending only the v1 version of the protocol. So what we're going to do is we're going to upgrade our roles to this new binary called version 1.5. And you can see that it's half green and half blue. That indicates that it can speak both versions of the protocol, but it's only going to send v1. So let's do that. So we're going to upgrade domain 0. Now notice here that this web role in this upgrade domain, it's still speaking protocol version 1. And the reason why it has to is because we still have this other role here in upgrade domain 1 that speaks the old protocol. Okay? This is what I meant earlier by you need to make sure that you understand the fact of having, when you're doing with rolling upgrades, the old version running side by side with the new version. So let's continue with the example. So we continue our upgrade. So now we're done upgrading all the binaries to version 1.5. So the web roles know how to, and the cache roles know how to speak the protocols for version 1 and 2, but the web roles are still sending version 1. So now once that's done and everything looks OK, we're going to do an upgrade to version 2 for just the web roles. Okay? So we're going to do a rolling upgrade here for the web roles, since they're the ones that are initiating the communication, because we want them to start talking v2 protocol. So we'll do that. So this web role in UD0 is now talking the version 2 protocol. But notice that this cache role, it can still speak both versions. And it needs to, because there's still older web roles in 1.5 speaking v1. Okay? So it actually takes requests from the web roles in UD0 in version 2 protocol, returns them. It takes requests in UD1 with the web role speaking the version 1 protocol and successfully returns that. Now we continue this upgrade process, upgrading the web roles. And as we flow through the upgrade domains, at the end of it, we now have all the web roles speaking version v2 of the protocol. And now we have actually done our successful upgrade to the v2 version of the protocol. Now, you also notice that the cache roles are still speaking, or still have the ability to speak the version 1 protocol. It's not that important at this point in time, because it's only speaking v2 protocol. So at some later point in time, we can upgrade these with another rolling upgrade to just get rid of that code. And then everything is now speaking and only speaking version 2 protocol. So that's at a high level how you can use the rolling upgrades to sweep through your roles to upgrade to a new protocol while still maintaining complete availability and allowing all the roles to still correctly communicate with the correct protocols to each other. Now I want to go through an example of using Windows Azure tables for a schema change to show how the same type of thing will work for that scenario. So assume that for our table that we have a version property. And the types of the schema change that you may want to do range from the following. You may want to add new properties to your table. And to do this, this is a very similar step that I just talked about, two-step process. Plus, you will probably want to use for your ADO.NET use of the tables, ignore missing properties. And I'll explain that in a few slides. Another type of schema change you might want to do is to remove properties. Again, this would be a similar two-step process. And then along with ignore missing properties, you would want to use replace on update with ADO.NET. And what replace on update does, it will actually make sure you actually delete that property when you actually update it. Then a more invasive change for your schema would be actually to change the partition key or row key, which is basically changing your primary key. Now, there are many ways to actually try to do this. One way would be to actually have a new table that you created with that new key, and then copy the entities from the old table to the new table, but I don't have time to go into the details of that type of schema change. The most common type of schema change services deal with is basically adding a new property. So I'm going to go through an example of doing that right now. So here we have two clients talking to this Windows Azure table. The two clients are spread out across upgrade domain 0 and upgrade domain 1. And here's our table where we have a partition key, row key. We have a version column. And what we want to do is add a new property to this table. Okay? Now, we're both executing right now across both upgrade domains client v1. This client v1 speaks just the version 1 of the class definition. So it knows how to process version 1 of the class definition, and that's it. What we want to do is upgrade these clients with our rolling upgrades so that they use the new class definition, which has this extra property. So how does this work? So let's say we're going to do our rolling upgrade, and we upgrade UD0 to support a client that actually has this new class property in it, but it basically knows what to do for an entity of version 1 or an entity of version type 2. So just go through an example of how this works. So we've upgraded this client to v1.5. This client has the new property in it. When it accesses this table and retrieves the entity, it'll get back the properties, and it realizes that this is a version 1 entity. So it's going to update it with a version 1 piece of code, and then just put a default value into the new property. Okay? Note that it doesn't actually update the version because it knows that this is version 1, and I need to respect that and update it with version 1 code. Now, the v1 client that is still running here side by side with the new version, it only knows how to speak v1. When it goes to access this entity, it's going to come in, and it's only going to know how to deal with these properties. It doesn't know how to deal with this new property yet because its class definition in its client doesn't have that property in it. So in order to deal with this in ADO.NET, you need to specify ignore missing properties. Because what will happen is that the server will return all these properties to the ADO.NET client. And the ADO.NET client will say, I have this class definition. I don't know about this new property. What do I do? Well, if you say ignore missing properties, that new property will be dropped. And then you'll be able to successfully process this entity request as a version v1 request. Okay? So now what we want to do is finish our rolling upgrade with v1.5. And once we've done this, we now have all of our clients able to process entities in version 1 and version 2, but they only keep on inserting entities and updating entities in version 1. And so the next step we want to do is actually do another rolling upgrade to convert all of the clients to actually start using the new property and convert all the entities to version 2. So let's go ahead and do that. So we do an upgrade of domain 0 to the version 2 client. And what it does is when it takes this entity, it knows that, OK, it's a version 1. I want to convert it to a version 2 entity and start using this new property value. So it can go ahead and do that. So we see a version 2 here and a real value in the new property. Now, when the version 1.5 client comes along, just to remind you, when it processes an entity in version 1, it still respects that version number. So again, it basically will just update it with the version 1 code and just put a default value in there. But this client actually knows how to deal with version 2 if it sees it. So when it accesses this entity, it knows I got a version 2 entity. I can actually then use the value and update it with my version 2 code. Okay? And this is how you deal with the side-by-side version 2 client with the version 1.5. Okay? So when you're done, you're now going to continue doing the rolling upgrade, and you finally have basically updated all your clients so that they can speak with the new class definition with the new property. And at this point in time, you may also want to run a background job which just goes through and converts all the v1 entities to v2 entities. This will naturally happen because the v2 client knows how to do that, but you may just want to sweep through and do that just to get the conversion over. Okay. So just to summarize this rolling upgrade process, this is very similar to the two-phase process we just talked about earlier with the protocol change. Here you have your v1 code with this class definition, and it only knows how to deal with entities with these properties. You then want to introduce a v1.5 version of the code that only creates v1 versions of these entities, because there's still other v1 clients out there. But it actually also knows how to process entities of both version 1 and version 2. But it doesn't do any conversion. Then after that rolling upgrade has rolled through the system, you then would upgrade the clients to v2, which converts all the entities to version 2 and always creates version 2 entities. OK. So the takeaways from this talk are that I hope I gave you some idea and insights into the data scalability of our system and how we leverage partitioning, and give you some understanding in terms of how to partition your data, and think about that. Then when you use our Windows Azure to build scalable applications, you should definitely look at using the worker queue model, because using the queues really helps enables you to basically build out scalable applications where the messages provide guaranteed delivery to workers even when the workers fail. Then finally, for lifecycle management, the in-place upgrades that we recently introduced are very valuable, especially for dealing with upgrade issues and realizing when those occur really early on in your upgrade process. And then when you do the in-place upgrading, you really want to keep in mind that you always have the old version of the code running next to the new version of the code as you sweep through the upgrades domains. And then in doing these upgrades for versioning, or like a schema table change I went through, you might keep in mind the two-step pattern we went through to doing that upgrade. OK. So thank you for coming this morning and dealing with the availability issues we had at the beginning of the talk. And please enter your feedback online. And if you have questions, please use the mics.
We've seen a lot about the different methods of deployment, whether that's rolling or VIP switch or whatever. But what I'm interested in is how do you combine that with the SQL Azure updates that you have to make? So if you want to update your code and you want to update your SProcs, or you want to change your schema in SQL Azure, how do you, sync those up at all?
In doing a change with SQL Azure, I believe a change that we talked about here for this table schema change could be extended to that. Because the point is that you have, like for rolling upgrades, you have your clients that need to be upgraded in a rolling fashion, and you have to deal with SQL as an endpoint that you're talking to, which has a given schema or a given stored proc. So I think you could apply a similar type of mechanism to that. I can talk more about that offline if you want.
But you probably would have to do that yourself, or is there any tool provided or anything? Syncs up.
Yeah, at this time it's basically, I think, roll your own to do that. But I think over time we need to have more patterns and maybe more infrastructure for that type of stuff.
Thanks.
Hi.
Hey.
I had a couple questions about the data scalability. The first is you reference small and large blobs and the different throughput for each. What's a small blob and what's a large blob?
So small blobs on the order of kilobytes in size. Large blobs, megabytes in size.
OK. And then on the latency numbers you list, are those latency within the cloud, or is that kind of to the glass? So if I'm in Topeka, Kansas, is it 100 milliseconds, or is it only if I'm running my compute in your cloud?
Yes, those latencies, I should have clarified that, are basically within the cloud, within the same geolocation.
OK, thank you.
Okay.
Yeah, Microsoft has a product called Stream Insight, which does complex event processing using multiple queues. It seems to fit the model that Azure has to offer quite well, because we have queues in SQL Azure. Is there any plans to make this available?
The streaming queue model?
The Stream Insight,
Insight?
which does the complex event processing.
I actually don't know the details for that question. So I, hopefully maybe go to the open sessions afterwards that are in the lounge, and maybe ask somebody there. Maybe they will answer for that.
Thank you.
Okay.
So during the upgrade process, when you take one of your domains offline, as you say, UD0, is there a way just to hit UD0 to see if that software is running correctly and then put it back And the rotation?
Yeah, right now you can actually specify exactly which upgrade domain you want to upgrade. What I don't know right now for the connectivity that we have for the service is if you're able to determine exactly what's in the upgrade domain 0. There should be a way for you to determine that, but I have to actually, is there somebody from the Fabric here that would know that? So again, go to the lounge, and I think that they may have the answer for that question.
Because then you could essentially take it offline
Yep.
and find out it and test it, and then put it back in rotation. So.
Yeah, well, typically the way you deal with this is that you'll do your upgrade domain 0, correct, and you might want to hit something just there to make sure it works before continuing.
Right.
Yep.
Right. Thank you.
Do you have plans to support the priority queue?
That's a feature request we've had. We don't have plans at this time, but we're considering it.
Another requirement is the job management is a pretty common requirement. So will be a library provided from Azure team, or we need to develop by ourselves?
Like a job scheduling sort of system?
Yeah, like in the task scheduling, queue task, abort stuff.
Yeah, we've been thinking about that, but we don't have anything that we can talk about at this time.
Okay,
Yep.
thank you.
So my question is about the security patches and operating system upgrades Microsoft would be applying to the cloud. Which policy is applied there?
Basically, the OS updates is something that we'll be defining now and clarifying in January. So basically, one very important aspect of actually running in the cloud is actually when should you upgrade your OS and how much control do you have of upgrading your OS. That's something, again, we have some OS experts in the lounge that can talk about. I think they may be able to talk about this time what our plans are for there, but I'm not sure if that's disclosed yet.
Yeah, the point is for us if we have enough control when an upgrade is applied or not. Yeah,
the goal is to actually give control to the users on when to apply an upgrade. Yes,
right.
That is the goal.
I have a question about the web role, worker role pattern, basic one. If a web role puts a job on a queue, the worker role takes the job off the queue and performs the work. What does the user see, or how does the user know that the job is done to refresh the screen on the web role? Is there a pattern there, or what would you recommend?
Well, typically you'll dequeue the item from the queue to a worker role. The worker role will finish processing that, and then it'll delete the item from the queue. Once it's done processing that, you could then log that to at least our logging system, so you could then get that and see that elsewhere, or you could actually communicate that to something else that you use for your application. Is that?
But from the user's point of view, what's the user going to see? How does the user know the job is done?
Right now, it's something that you have to roll your own. So once you actually run the job with your worker role, you can actually log a message using our logging infrastructure, and then look at those logs to basically figure out that the job is done. Or there could be some other mechanism that you roll on top of that to communicate that the work got done.
Okay. Yeah.
Yep.
Yes. You talked about dealing with the crashing worker roles. What about hanging roles? How would you deal with a worker that hangs and does not respond anymore?
That's a good question. So in terms of the work item itself, the work item will become visible again. Somebody will process it. That's where the job manager comes in to basically monitor what's going on with the worker roles, and then basically it could actually decide that I need to deal with that.
How can it detect that a role is hanging? Does it have to ping it, or is there any other ways?
Yeah, so typical ways that you deal with this in the service is that the worker role itself could actually have some logic in it to raise an alert or log something if it's not making forward progress. Another way to deal with that is you could have your job manager doing a heartbeat to the worker roles to make sure that they're still doing what they're supposed to.
Okay.
Yep.
Thank you.
A question about the best effort FIFO you guarantee you made. It is only due to the visibility mechanism, or there is also other reasons due to scalability?
You mean the reason for the best FIFO?
Yes.
The best effort FIFO? Well, the main reason is the fact that these messages may go invisible and then come visible again. And right there, that means that the messages can get out of order in terms of when they're processed.
It is the only reason.
Well, that's the main reason. And there's also a few other things in terms of scalability, but that's the main reason.
OK, thanks.
OK, thanks.